Catalysts. Catalysts are substances that increase the rate of a reaction. They are not consumed in the reaction, though they are intimately involved with the reaction. Here's a reaction energy diagram for the decomposition of hydrogen peroxide, which normally occurs in a one-step mechanism. Catalysts increase the rate by decreasing the activation energy of the reaction. They do this by providing an alternate mechanism for the reaction. This mechanism usually involves more steps, but the energy needed for each step is less than the energy needed in the other original mechanism, so the reaction goes faster. A typical catalyst gets changed into something else during the course of the reaction, then gets regenerated by another step in the mechanism. Thus, the amount of catalyst is unchanged, and the individual catalyst molecules can go on to catalyze another reaction. This means that generally a relatively small amount of a catalyst can have a very large impact on the rate of a reaction. In the example of the decomposition of hydrogen peroxide, the one-step mechanism is simply the overall reaction. This has a significant activation energy, so it is not a fast reaction. The catalyzed reaction, on the other hand, has 3 steps. In step 1, H2O2 reacts with HBr to produce water and HOBr. In step 2, the HOBr reacts with another HBr to produce water and bromine. Finally, in step 3, the bromine reacts with H2O2 to produce oxygen gas and HBr. Note that there are intermediates, in this case HOBr and Br2. As usual, these are produced in an early step and used in a later step. The HBr, however, is a reactant in an earlier step and is reproduced in a later step. This is how a catalyst is recognized in a mechanism. It is a reactant first and a product later, and is not part of the overall reaction. Note that the HBr is not present after the second step, and is formed again in the third step. The overall reaction is still the same, as it must be. A second type of catalyst is the type that most metals are. These catalysts provide a surface on which the reaction can occur. This surface is particularly active because of the unfulfilled bonding of the metal atoms near the surface of the metal. When molecules bond to the surface molecules, it holds the molecules in place and weakens the bonds, particularly pi bonding. Here is a reaction between ethylene and hydrogen. The double bond of the ethylene bonds to the metal atoms at the surface, tying the ethylene down and weakening the bond. The hydrogen molecule also attaches to the surface atoms of the metal, breaking the bond and producing hydrogen atoms. The hydrogen atoms migrate across the surface of the metal and eventually come into contact with the ethylene. A hydrogen atom forms a single bond with one of the carbon atoms, making 4 single bonds on the carbon and breaking the bond between that carbon and the metal surface. When both carbon atoms have bonded with hydrogen atoms, the molecule, which is now ethane, is released from the surface because there is no longer any pi bonding for the metal atoms to hold on to. You should note that the metal is not really changed in the course of the reaction, but only provides a place where the reaction is more likely to occur because of the partial breaking of the bonds and the change of the reacting space to a two-dimensional surface from a three-dimensional space. The partial breaking of the bonds is what lowers the activation energy for the reaction. Enzymes are a third type of catalyst. These substances are usually active only for specific molecules because the catalyzed reaction involves the fitting together of that molecule and the enzyme, with some internal activity in the enzyme that helps break apart the larger molecule. The molecule, called a substrate, must have a specific shape to fit into the enzyme. So these catalysts are very specific about the molecules they will take to react with. Once the right molecule is in place in the enzyme, something happens in the enzyme that helps to break the molecule. One example of this type of enzyme is seen in people who are lactose intolerant. Such people are missing the specific enzyme, lactase, which can break down the milk sugar, lactose. Without enzymes to speed up the decomposition reactions in the body, life would be impossible for most creatures.